So I had to pick a medium problem for today because I opened some hard problem and after half an hour I couldn't solve it at all, and I have to dial back down to mediums. Count ball subarrays. So we got a subarray with distinct element. It is a ball if it has length at least 3 and minimum of its 2 ends is strictly greater than maximum of elements between. That's literally what trapping rain is. And the previous problem I tried was trapping rainwater too. That is crazy. Number of ball subarrays. This was exactly the solution I was coming up for 1D. Okay, let's see if I can actually finish thinking about it. So what I need is a sequence like this, and then whenever a new guy comes in, so let's go into C++ because why not? And then we maintain like a stack or something of positions. Stack. While first I want to clear them. So let's say I have already something and then a new element comes in. I want to find an element. So I'm at some position and then I want to find the furthest one that is at least larger than or equal to all the previous ones. And if I move, well, the answer could change. Like here the answer is this. And then 5, 1, 2, 3, 4. Okay, this should be doable. I should get back to learning. I'm supposed to learn paths, but I really am lazy extremely. Ridiculous. So let's say if I computed answer for some I, right? so I am pointing at some position and I computed the answer for I. How can answer for I plus 1 change? Well, if it's smaller, then that's easy. There is 0 subarrays smaller than or equal to. Now if it's larger, that starts to be interesting. Question is, do I wanna, even if it's smaller than or equal to, do I really wanna throw out everything? So this one is larger than all the previous ones. This one is larger than all the previous ones, and this one is larger than all the previous ones, and I keep those 3. And then when I new one in, I erase this, and then when I put a new one in, has anything changed at all even? I mean, not really, I basically just added there. Now when a new element comes in, and it's larger, then I got some elements in there, which is this guy, and then this guy, and then this guy, and then this guy. And then I pop all the ones that were smaller than me. Okay, so I'm gonna explain the logic. If a new element comes in, then first I wanna pop, so while not stack empty and stack top is so I want to pop all the ones that are while all the ones that are smaller blah, 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 blah. So I want to pop. They really want to pop smaller ones. Well, I clearly want to pop at least the first one if I come in. I am so stupid right now. So, until when do we pop from the stack? Well, when a new number comes in, let's say we have 2 and then 5 comes in. So 2 is larger than all the next elements. So I leave it in there. Now 5 comes in and we are like, okay, well, I pop all numbers. Well, 2 was in the previous one, so I have to pop 2. And then there is nothing, like, so it don't do anything. And then 3 comes in, and then I put it back there, and then 4 comes in, and I put it back there. And now 1 comes in, I put it back there, put it on top of the stack, and now 4 comes in. So I pop 1 because it's the previous one. And then what about the rest? Well, I guess I can put them there, I don't know. So let's say 4 comes in, so I pop the first element if it's 1, and then not really, because I also have to, what do I need to pop? I mean, like at least 3, so if length is at least 2, we erase it. But then I also have to erase, if I'm larger, then I have to erase all ones that were smaller than the deleted element. So in this case, nothing. But if there would be like 6, 5, then like if instead of 4 I here will have 5 and then 6. Well, with 5 I would just erase 1 and we are done, and answer is 2. But if there is a 6 here and a 5 here, then this 3 is not sufficient enough, so I would have to erase it. And then I also would have to erase 5. And if I come as a smaller element, so if I'm smaller than the last inserted element, so let's do this. If I0 stack push I continue. Great, and now if a smaller element comes in, then what, the previous one? previous one, all the previous, it's always gonna get pushed, so if the empty or so if I would kick out this, and now I go for I would insert 2. What happens with 2? Okay, but if 5 comes in, I also have to delete. So I delete 1. I already forgot. Okay, so I have 531 there because that's decreasing, and then suddenly I will be like, okay, 5 comes in, and now 1 is previous, so we kick it out. But what else do I have to kick out? Well, all elements that are no, I don't have to actually. The answer is 2. And do I have to erase anything? Well, then I have to erase elements that are smaller than or equal to me after I insert myself. So first I kick out previous one. So if not stack empty and nums stack top larger than or equal to nums I. No. If stack top plus 1 is equal to 1, then stack pop okay, and then so I erase that guy. Then unsplit equal 1 ll times stack size, and then one ll stack size. And now until when do I pop from the stack? It should be I equals 0. While not stack empty and nums stack top smaller than or equal to nums I, stack pop, and then maybe that's it. I'm not sure. This might be stupid, but answer 0, 0, 0 every time. That's great. Oh, and I need stack push I. Still 0. That is awesome. So I push 2 and continue. and then it's not 0. So if not stack empty and it's the previous one, and I don't want to pop like this, bruh. And nums, okay, and nums I minus 1. Why would I pop in this case? If it's the same, if it's more than or equal to nums I. 5? What? So after I is equal to so for this position we do 0. So there is 0 here, 0 here. I mean that should not really be the case because it don't really want to do that. So I pushed 5 in there. And then what if I'm smaller? Then nothing should happen. Would be ok. Why would it be 1 here? gotta be some error in here. Oh, I'm outputting the wrong thing. Just test case bool. So what's wrong? 4312. Okay, I didn't think about the case. Not actually, not actually. So no. This guy comes in and maybe like that it will pass, but now more cases won't pass. Oh, okay. This is the most dog water solution of all time. I don't even know what I'm doing. What the fuck? Oh my days, okay. No editorial, great. Let's make my this could probably be done 10 times. Okay, stack. So I don't know, I guess like monotone stack. Monotone stack. Shit. For each let's calculate number of balls ending at some position R. Suppose we have stored the starts of balls ending at some starts of balls L, ending at some position R. Now what happens when we move to R plus 1? Approach. When we move to R plus 1, we have a few cases. The previous, we have two cases. The previous element is the current one. In that case, we first remove the previous, we remove R from our list of starts of balls. The previous element is greater than the previous, greater than or is then greater than or equal to the current one. In that case, we just push R plus 1 at the end of our starts of balls list and move to the next element. If the move to R plus 1 in the previous, shouldn't be less because one more ball, buy one more ball. To je chyba potom, ale keďže tam má 6, 5, 1, 5, Tak by mi to mal nájsť iba jeden, ale toto mi nájde. That's weird. Let's save this. What if I add my own test case? Like that. They're unique. Oh, they're unique. Oh, why am I? Wow. They are unique. What am I even doing with this? Oh my days, bro. They are unique. Are you kidding me? Smaller. If before him cannot, since the last candidate would be larger than or equal to the right end of the balls. We do not, however, have to remove the last or any other candidates before him, since they are larger, they are all larger than r plus 1, and therefore can possibly form balls with going beyond r plus 1. Finally, if we got to this point in the evaluation of r plus 1, we push it on top, we push it to the end of our list of candidates. Note that the list of candidates can be represented as a stack. And since each element will be pushed and popped at most once to slash from the stack. And the extra work is only 1 per iteration. Of since when the nonce array is decreasing, we will store all elements in the stack. Okay, this was a little painful, but I came up with it in sub 45. Okay, that's it, goodbye.